Okay, just a quick few problems to review Chapter 6. First off, this should say Chapter 6 and not Unit 7. Typo I did not notice until after I had made 100 copies. So if you could just cross that out so you don't get confused later, that's great. The first situation we come to is a situation where we're trying to estimate a mean when we know the standard deviation. Now that is the most important piece of information here. The standard deviation of the population is known. That means you should expect your problem to say something like sigma equals, or the standard deviation of the population is known to be ... with the answer. Okay. You need to use an error formula, which is on your formula sheet, that uses a critical value z sub c, the standard deviation, which you should know, and the sample size. You're going to get that critical value off of the confidence table that's in the corner of your z table. So for example, if you know that the confidence level is 80%, then you would make your z 1.28. Once you've got your error, you add and subtract it from your average estimate to get your confidence interval. So for example, at a local high school, a random sample of 50 students were measured and their heights in inches were recorded. The sample mean of the height, x bar, equals 58 inches. Assume that the standard deviation is known, doesn't get much clearer than that, to be 5.8 inches. Find a 98% confidence interval for the entire student population at the high school. Give a brief interpretation of the confidence interval in the context of this problem. Okay, so I know I have a sample of 50 students. So there is my sample size, 50. Okay, so that means I know that I have a random sample. I know my sample size is bigger than 30, and I know that my standard deviation of my population is known. Conditions have been met. The sample mean says x bar equals 58, and the standard deviation is known to be 5.8 inches. Okay, I'm supposed to find a 98% confidence interval. So the confidence interval has a C value of 0.98. Okay, first thing I'm going to do is recognize I know my standard deviation. That means that the error formula that I wish to use for this is z sub c times the standard deviation over the square root of n. I have the standard deviation, I have the n, I need the z. Get that z off of my table. If you look up, you're looking for z sub 98, or the z-score that goes along with the 98% confidence level, and you should see that that's 2.33. And you can see that on the table above. All right, so I'm going to plug all these into my problem. My error is 2.33 times 5.8 over the square root of 50. You're going to plug this all into your calculator. I'm going to go ahead and round to 1 decimal place, and I end up with an answer of 1.9. So my margin of error is 1.9. For my confidence interval, I'm going to take my estimate, my x bar, and I'm going to stretch that by my margin of error, or I'm going to take and move out in either direction. So I'm going to take 58 minus 1.9. That's going to give me 56.1. And I'm going to take 58 plus 1.9. And that gives me 59.9. There's my confidence interval. You could also write the confidence interval like so, 56.1 to 59.9. The question did say to interpret it, so the idea is you would say something like, I am 98% confident that the interval 56.1 to 59.9 contains the true mean. All right, next page. So let's say that your standard deviation is unknown. Okay, you do not have the standard deviation of the population. You only have the standard deviation of our sample. That means that you're going to need to use the t table, because your error formula in this situation uses t. To use t, you're going to need your level of confidence, which is located across the top up here, and your degrees of freedom, which are located down the side. Remember that degrees of freedom equals n minus 1. And if yours isn't there, you pick the next one that's smaller. Okay? All right. So Confidence interval is constructed pretty much the same way. John is selling vacuum cleaners door to door. He wants to estimate the amount of sales at the end of each month. A random sample of the last 24 months had a mean of $2,500 and a standard deviation of S equals $350. Find an 80% confidence interval for the mean amount of sales each month. Give a brief interpretation of the interval in the context of this problem. Okay, so standard deviation is unknown. I do have a random sample of the last 24 months, and I'm going to say that my sample size here is 24. We know we have a X bar of 2,500 and an S of 350. So the standard deviation is unknown, so I know that my error is going to be T sub C times S over the square root of N. I have S, I have N, I need T sub C. To get T, I need to know my degrees of freedom. Degrees of freedom is N minus 1, so we're talking about 23. I also know that I need to be 80% confident, so my confidence level is 80 here. All right, so I'm going to go up to my table really quick. Degrees of freedom 23 tells me I want to use that row of 23. And confidence level of 80% puts me here, so I'm going to look down. My T value I want then is 1.319. All right, so 1.319 times 350 over the square root of 24. Okay. And I am going to go ahead and round this. Since we're talking about months, I'm going to go ahead and round it to the nearest, sorry, we're talking about dollars, the whole dollars there. I'm just going to round it to 94. So my X bar is 2,500. I'm going to make this rounded to 94. Calculator here. All right, so my X bar, I'm going to take X bar minus the error and X bar plus the error. So I have 2,500 minus 94, which ends up to be 2,406. And 2,500 plus 94, which ends up being 2,594. So this is his monthly average, okay? So this is the average per month. Basically what we're saying here is that I'm 80% confident that the average per month that he makes is somewhere in between $2,400 and $6 and $25.94. So for 6 months, if you took this answer and multiplied it by 6, you could represent 6 months here. That would be 14,436 and 15,564. Okay. All right, so again, just a different way of getting that critical value. The third type of problem that we worked was one where you were dealing with a binomial distribution with success and failure. Okay, this error formula also uses a Z. We are going to have to find that p hat estimate of our population first. So a random sample of 100 students, okay, n equals 100, at a local high school found that 75 say they watch TV for more than 2 hours a day. So 75 is the number of successes in our problem. Find a 95% confidence interval for P and make a brief interpretation. Okay, so first off, my Z-score that I need for my error formula for 95% is 1.96. The other thing that I need for my error formula is P hat. P hat is the success rate, so we're talking about 75 out of 100. That's 0.75. And Q hat, that would be the rest of that. 1 minus 0.75 is 0.25. All right, so for my problem, I'm going to say my error is 1.96 times the square root of P hat, 0.75, times Q hat, 0.25, divided by N, which is 100. When I put that into my calculator, I'm going to go ahead and round that to 2 decimal places. I get 0.08. Okay, so my confidence interval uses p hat instead of an x bar, obviously, because we have p. So if I take p hat minus the error and p hat plus the error, I should be able to get something in between. All right, so 0.75 minus 0.08 and 0.75 plus 0.08. So I end up with 0.67, which is less than p, which is less than 0.83. So I would say I am 95% confident that the true proportion is somewhere in the interval 0.67 to 0.83. And remember, what we're really saying here is that 95% of confidence intervals would contain the true mean. All right. The other thing that we did, the very last thing, was determining a sample size. There were three formulas for determining sample size, a minimum sample size. One dealt with mean, so if you're given the standard deviation in your problem, that is going to be the first one. If you have a preliminary estimate for your percentage, you use this guy right here. And if you don't have a preliminary estimate, then you use the one with the 1/4. That's basically assuming that p and 1 minus p are 0.5. Okay. A study is planned to estimate the mean. Oh, look, there's the word mean. N equals z times, or z sub c times the standard deviation over the error. Okay, let's go ahead and get that down there. A study is planned to estimate the mean number of hours a student at a local high school watches TV. The population standard deviation is assumed to be 5.6 hours. Okay. How many students should be included in the sample? What's in? To be 95% confident that the sample mean will be within 1.5. Now that within 1.5 is telling me that I have an error of 1.5. The 95% confidence is telling me that I need to get my z sub c from the table. Z sub c for 90% confidence is 1.96. All right, so 1.96 times 5.6 divided by 1.5, quantity squared. If I put this in my calculator, I end up with 53.543. Now, n has to be a whole number, so I can't use 0.54 of a person. And remember, this is a minimum. We cannot go any smaller than that, so we're going to use 54 as our sample size. So even if this had been 53.0000003, I still would have went up to 54. Let P be the proportion of students who own an iPhone or other smartphone. What sample size is needed to be 99% sure that the point estimate P hat will be within 0.05 of P? Okay, there's our error, within 0.05. Sample size 99% sure. I need a z-score for 99%. If I look on my table, that one is 2.58. So I'm trying to estimate a p hat, but I don't have any clue about what p hat is. So that's going to be without a preliminary estimate. So I'm going to use the one that's 1/4 z sub c over the error squared. Okay, so that is 1/4 and 2.58 over 0.05 squared. I end up with 665.64 and some change. Remember that we're going to round up. Don't freak out about that. It is just the answer to our problem. All right. So I take my answer, I round up. The next one says, let P be the proportion of students who are saving money for college. A preliminary study shows that 76% of high school students are saving money. All right, so there's my preliminary estimate. That tells me that I think P is 0.76. How large a sample is needed to be 98% sure that the point estimate P hat will be within 0.08? All right, so my error is 0.08. And 98% confidence means that I need a z-score for 98%. If I look that up on my z-table, I get 2.33. Because I have a preliminary estimate, I'm going to use p times 1 minus p times z sub c over the error squared. So that gives me 0.76 times 1 minus 0.76, 2.33 over 0.08 squared. I punch this in my calculator. I'm going to end up with $154.72. No, sorry. This is a number, isn't it? 154.72. Again, it doesn't matter what that decimal place thing is. I'm going to round up. Always round up on these because this is a minimum equation, so you can't go any smaller. Okay, that is basically one of every kind of problem that we've done in this chapter. This video will also be posted on Schoology, so if you want to watch it again because you're super excited, you're welcome to do so. Also, a keyed-in copy of the notes is on Schoology as well.